Once again, we are going to integrate sine x from 0 to 6. That is the area in red. The green segment will be ignored. This time we are going to use Simpsons 3/8 rule. For starters, we are going to split the interval into two separate segments. So here we have two panels. Each one is the curve of a third-order polynomial, interpolated through the data points. This is the sigma notation of Simpsons 3/8 rule. We derived this in the last lesson. This is a data table for y equals sine x. It is the exact same data table we have used for every other method of numerical integration thus far. Using the same data for each method will give us a meaningful basis of comparison. As we did with the first Simpsons rule, we introduce a fourth column for weight. Other than the ones for the first and last data point, each y value is multiplied by 3, except the middle one, which is multiplied by 2. I've emphasized that difference with a blue box. The fifth column is the product of terms in the third and fourth columns. The sum of all those is boxed in red. If I multiply that by 3/8 times the mesh size h, I get my final answer, boxed in green. What if we reduce the mesh size from 1 to 0.5? Well, here's the data table for that. Same idea as before. Notice the symmetry in the fourth column. 3, 3, 2, 3, 3, 2, 3, 3, 2. The same pattern continues for even longer data tables. Anyway, add up the values in the fifth column and multiply by 3/8 times the mesh size h. That gives us the final answer in green. I've just given you the pattern. Now apply it to 8 and 16 panels for yourself. See if your results match mine in the table shown here. As we've seen before, the error is calculated as the difference between Simpson's rule and the true value of the integral. We've seen this plenty of times also. In each row, the mesh size is cut in half. Equivalently, we are doubling the number of panels. Dividing subsequent error terms seems to be converging around 16. Since 16 equals 2 to the fourth power, we say this method is fourth order, h to the fourth in big O notation. Now let's compare the numbers to the other methods. In the top left, the trapezoid rule without end correction is only second order. Everything else is fourth order. How do the numbers compare? Which ones give us the best results? In order to compare apples to apples, the numbers in the first row have the same mesh size, h equals 1. Same thing for the second row, except h equals 0.5, etc., etc. This means we are using the same number of data points in each row. However, notice that the number of panels is different, 24 versus 48 for Simpsons rule in the bottom left corner. Why is that? And in the bottom right, how about 16 versus 48 for Simpsons 3/8 rule? Think about that. This is a good conceptual check. If you aren't able to come up with the answer, it may mean you don't yet have a thorough grasp on this topic. That's okay though. These things take time, so I encourage you to spend as long as you need practicing these methods until you feel comfortable. Practice makes perfect. I appreciate your loyal support in watching these lessons and taking the time to learn these concepts. If you know someone else who could benefit from these lessons, I kindly ask that you share them liberally. It would help me out greatly in continuing to produce instructional material. Feel free to share your feedback in the comments section below. That will also help me to improve the quality of these lessons. Until next time.